Section 3.1 is a short introduction on using vectors, and before we begin, we'll remind you of some things that we saw in a previous lesson. One of them is the idea that vectors can be added together tip to tail. That vector A represented here and B represented this way can be added together so that the tails and tips are connected, as shown in this picture. And in doing so, we see the resultant, vector A plus B, the addition of vector A plus vector B. It's shown by this red arrow here. It starts at the beginning of this chain of vectors and points to the end of the chain. Now, a couple of other things that we can do that we haven't really talked about before is the fact that we can multiply numbers into vectors. That's saying that we can multiply a scalar into a vector. So if this arrow here represents some vector that we call C, C could be multiplied by a number like, say, 3. So 3 times C, so the scalar 3 times the vector C, is really just taking vector C and adding it to itself 3 times, which is very much like what multiplication means in the scalar world. So this red arrow represents the vector 3C. It's 3 times the length of the original vector C, but it preserves the direction. It still points straight to the right in this case. So if you multiply C by a negative number, like -1, you flip the direction. So if vector C points to the right and is about this long, then minus C, which is the same thing as saying, -1 times vector C. That's how you end up getting minus C. It flips the direction around. And if the vector was like, if we did say -2 times C, then you would get a vector that's twice this length, but again pointing to the left. So we've seen adding vectors, but let's talk a minute about subtracting vectors. And subtracting vectors becomes important because we have all sorts of quantities in physics that are vectors that are changing. Even the concept of displacement. If you think of displacement as delta x, well, position's a vector. So this is really the subtraction of two vectors, a vector x final minus x initial. So understanding how we could subtract vectors is going to be important. So here's two vectors, A and B, as shown in the picture here. And let's say that we're going to subtract them. The way that we're going to do this is by actually kind of a trick in some respects, but we're going to add them. And to add them, we're going to add negative b, because adding negative b is the same thing as subtracting b. But we know how to do this. We know how to add vectors because we use the tip-to-tail method. And we know how to take b and put a negative sign in front of it. That's like multiplying by -1. That just takes the vector and flips the direction. So here's vector A. Here's vector B. Let's first find negative b. So it's this arrow, but pointing in the exact opposite direction. So then A plus negative b, that's tip-to-tailed in this picture. And the red arrow represents the quantity A minus b. So the red arrow is what happens when you subtract vector b from vector A. And just like in the normal mathematical world, A minus B is not equal to B minus A. Those are two different vectors. If you think about it, B minus A, that would be this vector B plus the opposite of A. And we could take a look at that really quick. I could take vector A and clone it here. I'll move it over, and I'm going to flip the direction by flipping it left-right and then flipping it up-down. So here is vector minus A. And I'll take vector B from over here just to show. If I tip to tail the vector minus A and the vector B, that's what this is, B minus A. What I end up getting is an arrow, a vector that looks like this. This is B minus A. Now you'll probably notice here B minus A and A minus B are actually the same length, but they point in opposite directions. A minus B is pointing up and to the left here. b minus a is pointing down and to the right.